Hey, my name is Russ Livesay. I'm a fire protection engineer. Wear a few different hats. That is one of my degrees, and my registration is in that field. So one thing that bothers me, Cameron Todd Willingham was executed in 2004 for a crime that didn't exist. I've used that as an example in each of these forensic analysis videos to explain the need to really correctly identify appropriate forensic tools. And a lot of false litigation has happened. A lot of criminal convictions have occurred because of arson when there was no arson involved. So the intent of these videos is to format a variety of topics so that people can understand and then provide an appropriate level of defense for any kind of criminal or civil accusation. So this analysis reviews concrete spalling. And in the past, you've seen testimony from experts that claim that spalling is due to ignitable liquids, and that's false. That's been proven to be false testimony. But a lot of individuals that are performing forensic or arson investigation witness testimony don't have a science or engineering background. So they're just going from kind of historical ideas passed down through fire chiefs without really digging in to understand the science behind it. So what this video does is it's going to go through and discuss the realities of concrete spalling. So to understand what concrete is the first step. Concrete is an aggregate. Basically 1 part Portland cement, 5 parts other stuff. The other stuff is sand and gravel. And during exposure, water is lost because of evaporation. And it's lost from both the crystalline structure of the Portland cement as well as the aggregate. And what that does is it lowers the tensile strength of the material. So spalling on concrete is the result of tensile failure at the surface. Here's an example of spalling on a wall. What you see happening here is the breakdown of the surface tensile strength is what causes it. And it shows up in a variety of features, cracking, breaking, chipping, and craters. And this is caused by the moisture presence in the concrete, as well as the thermal gradient from the surface toward the inside of the concrete that creates differential expansion rates. People have erroneously assumed that spalling is due to a difference in thermal expansion coefficients between steel and concrete. And as you can see, the difference between those thermal expansions is roughly 10%. But steel has a conductivity 50 plus times more than concrete, meaning the steel is effectively going to be the temperature of the concrete. And that 10% difference really doesn't make a lot of difference in spalling because of the compressible nature of steel. So the primary mechanisms for spalling is the gradient temperature difference in the concrete itself, resulting in differences in expansion, as well as explosive natures of steam generated within the concrete. And on this subject, people have misunderstood something about high strength concrete. So polypropylene, in some cases polyvinyl chloride, is added into concrete to stiffen it. Fibers are put in, these plastic fibers, and what happens during a fire is those fibers can melt, create voids for steam, resulting in steam accumulating at those locations under high pressure, and then resulting in explosive behavior. So what you're going to see is greater explosive behavior for high strength concrete than normal strength concrete. One thing during your analysis of a fire investigation, sometimes existing spalling is in place prior to the fire. So witness testimony or samples at other locations can help diagnose that the spalling was not caused by the fire. And if you're using spalling as a forensic tool, it's important to validate that it was not there prior to the fire occurring. So expanding water vapor within concrete pressurized heat-weakened surfaces that have lost their tensile strength due to that evaporation of the water in it. And that results in explosive spalling. And one thing that happens to that steel is that it's then exposed to heat. And about 550 degrees Celsius is where structural engineers claim that there's really no strength. And it's more gradient than that. but there's, according to structural engineering practices, that's the threshold at which you lose all dependable strength. Because there's very little tensile strength in concrete in comparison with its compressive strength, your tensile strength is effectively in the steel reinforcing bars for your concrete structures. So once you lose the tensile strength of your steel, that's where you're going to see serious concrete structural collapse. So a common mistake that's made in fire forensics dealing with concrete is in claiming that ignitable liquids cause spalling. And this has actually been testimony in cases before. It's not correct. It's just patently not correct. So NFPA 921 states that the presence or absence of spalling in a fire scene should not, in and of itself, be construed as an indicator or absence of liquid fuel accelerant. During a liquid fuel pool fire, what you'll see is a thin film, typically, depends on what it is, but between 0.7 millimeter and 2 millimeters in thickness. And that's typically the thickness of an unconstrained fuel spill. But liquid fuel fires have minimal direct impact on concrete floors, as the evaporative process prevents significant heat transfer. And what I mean by that is you have a layer of liquid, and as that fire exists, it does so on the gases emitted from the liquid. The liquid itself is not on fire. It's the gases, the vapors that occur. And the vaporization process, it actually lowers the temperature of the liquid. It maintains that temperature. So the reality is when you have a pool fire on concrete, your duration is going to be fairly short unless it's constrained. But even if it is constrained, the very nature of a liquid pool fire and that evaporative effect results in the liquid itself being fairly cool and certainly not warm enough to result in spalling. If in a rare situation you do have spalling, it's going to be on the periphery. The other thing that could happen is if you have a liquid ignitable placed on carpet and carpet pad that prolongs the fire. So the liquid accelerant itself is not going to burn very long, but that carpet, the plastics in it, could have an extended life resulting in some spalling. Overall energy transfer is dependent on time. It's not necessarily the temperature at a given point. It's the rate of heat transfer from that temperature over time. So liquid fuels can ignite adjacent combustibles. In this case, you see some wood ignited on concrete. That wood continues to burn much longer than your ignitable liquid, and that's what results in spalling. So here's an example from the former images that show the spalling under that wood. Spalling is likely to be produced over large, unprotected areas by radiant heat developed by normal fire propagation rather than ignitable liquids. So coming away, there's a few things. So first off, ignitable liquids in and of itself, they are not going to cause spalling. The temperature for the concrete under an ignitable liquid is typically going to be at or under 150 degrees Celsius. That's not hot enough to create spalling. And people have erroneously concluded that spalling is a function of ignitable liquids. It is not. There's no correlation to that. And Sherlock Holmes has just a fabulous quote that I think is very applicable to forensic science, particularly with arson. And keep in mind, arson investigation or fire investigation, it's referred to in past documentation at ATF and other, fairly credible sources as being an art. And there's no room for art in forensic analysis. You have to apply real tools. So it is a capital mistake to theorize before one has data. One begins to twist facts to suit theories instead of theories to suit facts. So there's just a little information on the generalities of concrete spalling that should be taken into consideration. It is a forensic tool. It can be utilized in tracing fire origin or the patterns of fire. But accusing someone, a defendant, of arson just because spalling exists and making the assumption that you have ignitable liquids is false. For instance, if you're dealing with a garage, you're going to have residual ignitable liquids on that may have been cleaned up years before. Sampling may find traces of gasoline in that concrete, leading investigators and prosecutors to conclude that it was an accelerant involved fire. But it doesn't take into consideration the history. For instance, here's an example. So I mentioned Cameron Todd Willingham before. He was that individual executed in 2004. Um, Kerosene residue was found at the threshold, and that was used as a piece of evidence that convicted that man and executed him. And he always maintained his innocence. But what failed to come up during the trial is that there was a barbecue on the front porch right next to the front door, and it had kerosene there. So over years, you could have spilt a little kerosene there in that wood, the vicinity, or the very nature of the fire occurring could have resulted in a kerosene bottle, melting and pouring kerosene at that location. So there's several reasons why kerosene could have been found at the location. Similarly, gasoline is often used to cut, use it as a paint thinner or as a solvent. And a lot of people fail to take that into consideration when convicting people when remnants of gasoline are found during a fire investigation. So I use these simply as examples to keep an open mind during a trial or any kind of things that are read about fire and accusing someone of arson. There's a lot more information and a lot more forensic tools that need to be applied for those analyses. Hey, thanks. This has been fun. Feel free to reach out if you have any questions or concerns about what was posted here. Appreciate it.